Okay, today we'll do logarithm. And logarithm is more like application of indices. We did indices in the last class. So the logarithm is an application, one of the applications of indices. For example, if I tell you that log p to this a is equal to x, this simply means that what? This is the definition of the log. It means that p is going to be equal to what now? A to the power of x. Log p to base a equal to x. This is the log of the number p. P is representing any number. The base is what? Is a. This subscript here is the base. Then what's the value is what now? Is x. And then I said if this is true, then p will be equal to a raised to the power of x. And then I'm going to show you an extension for this. I'll make an explanation. Let me do that quickly. Okay, so if for example I have log 30 to base 10, which I know is going to give me 1.4771 approximately, is going to be equal to, if you check 30, 771, right? That means log 30 to base 10, if it's equal to this, and which is true, log 30 to base 10 is equal to 1.4771. It's going to mean that 30 will be equal to 10 raised to the power of 1.4771. If you use your calculator to do this, you will get something like 29.99 something. 0.99, like, because this is approximated value, I'm just doing it to 4 figures, alright? If you have, excuse me, if I have 20, if you check for log 20 to base 10, this you can see in the log table. And even your calculators actually are programmed to base 10 for logarithm. Log 20 is going to be 1.3010. I don't know, and this point is not coming, okay? And this means that 20 will be equal to what? 10 raised to the power of 1.3010. That's what this simply means. And if I'm going further, let me put this. I'm trying to be slow so that you can get this basics before I start explaining the theorems, right? I'll explain the theorems afterwards. Also, if I have log 40 to this 10, it will give me 1.6010 approximately. Let's say 1020, sorry, 20, which is going to be meaning that 40 will be 10 raised to the power of 1.6020. Alright? So it means that this value here, okay, let me do one last one. Log 50 to this 10. I hope this is right. 1.699990. If I'm not so sure about that anyway. That means that what? 50 is going to be equal to what? 10 to the power of 1.6990. Alright? Now let me explain this. Right? So it simply means that if I have this log, sorry, can I use it right? Log 50, this is the number. 50 is the number, 10 is the base. Then this value that I get, the value of your log is always the power or the exponent. That means anytime you are doing logarithm, what you get is always a power for the number. Look at what I mean here. The 1.66 is what now? It's a power. See the power. The 1.60 is what now? It's a power. Do you get it? This is the base. Remember for indices, this is going to be base and this what now? The power. So log what now? Log 50 to base 10 is equal to what now? Base. That means if I'm writing 50, I can write 50 to give me what? 10 to the power of 1.6990. This is the first step I want you to get. This is the definition of what? Of a log. Let me try and okay. Take this back. Okay. I want to try something. If it's going to work, Okay, let me just do this here. But I don't need it. So if I give you something like 30 times 20, you know it's what? It's 600. If I say you should do it from log, it's going to mean that what now? 10 raised to the power of 1.4771 times what? 10 raised to the power of 1.3010. From law of indices, we add the powers. I think this color is not going to be so good. Let me change the fonts, please. The color of the fonts. So this becomes 10 to the power of what? 1.4771 plus 1.3010. At the end of the day, I'll get 10 to the power of 2.7781. And if you check this with your calculator, you will get 599 point something something something. You understand what I'm trying to say? So in the application of log, if you're doing this to apply for log, I will show you how this can be applied. This very thing I just did right can be applied for what now? For logarithm. Alright? Just hold on for a while. Okay. So the question I gave earlier on was 30 times 20. For 30 times 20, I showed you how you can use a calculator to get 600. And then how is it that you can use indices, knowing very well that this is the same thing from that log stuff we did. This 30 is the same thing as 10 raised to the power of 1.4771. And then 30 is what? 20 is what? The same thing as 10 raised to the power of what? 1.3010. So if I was going to use logarithm to do this, what is the log of what? Of 30. I already know is what now? From what we did earlier on, what I showed you earlier on is 1.4771. That is the value of log 30. Then what's the value of log 20? It's 1.3010. Now when we're doing indices, when we have powers for the same base and multiplying, what do we do to them? We do what now? We add. So we're going to what now? Add this to give us what? 2 points. This is 1, this is 8, this is 7, this is 7, which is what we got when we did that stuff there. Then after you've gotten this, if you are doing with log tables, so using your calculators, you now find the anti-log of this value. And then when you find the anti-log, you will get something about 599.9 something something something, right? Which is approximately what? 600. And this is because when we are given the log, we did it to what? To 4 decimal places. The log will continue forward and all that. So basically, I'm just trying to show you what the fundamental, what logarithm means, and how it can be applied. I'm not going to all this table stuff. What I'm going to do to a large extent will be theory of what now? Of logarithm. So let me pick it up from there. I'll take this off right now. Okay. So let me go back. These are the theorems, right? For logarithm. If I have log p times q, that is two numbers multiplying each other to the same base. Briefly, you are instructing me. Log p times q to the same what now? To this base. What will I have? I end up having log p plus I will not prove them because of time. I'll just show you applications of them. Log p times q is going to be equal to what? Log p to base a plus what now? Log q to what? Base a. When we are multiplying, we expand by addition. When we are dividing, log p divided by q, we expand by what now? By subtraction. And then if I have a power attached to the number, I can what now? Make that power to become the coefficient. So log p raised to the power of n to base what? To base a is the same thing as what? N log p to what now? Base a. The fourth theorem I gave here is what? That if I have a base, the number and the base are the same. The log will be equal to what now? 1. If the number and the base are the same, the log will be equal to what? To 1. Then any log of 1, log 1 to any base rather, log 1 to any base is equal to what now? Is equal to 0. Log 1 to any base is equal to what? To 0. Then log p, q, I can what? I can also what? Separate it into two different logs, dividing each other. That's log p to base q can be equal to what? Log p to base a divided by log q to base a, right? All of this, I maybe with time I'll make a video to explain the theorems, but for now I just want to use them to solve what? Solve questions. Is that alright? Okay, let's just pause for a while.